Okay, next up for us here this evening, it's really, I feel super lucky to get to introduce one of my teammates tonight. Our next presenter this evening is Matt Primomo. Matt is an avalanche forecaster who's worked with the Northwest Avalanche Center since the winter of 2017-18. Matt lives with his wife in Leavenworth, Washington, where he's responsible for writing the avalanche advisories for Stevens Pass and our East Central zones. Matt is a certified ski guide with the American Mountain Guide Association. He's a professional instructor for the American Institute of Avalanche Research and Education, or AIRE. He holds a bachelor's degree in geography from the University of Colorado, an associate's degree in outdoor recreation leadership from Colorado Mountain College. In the summer, he works as a mountain guide for Northwest Mountain School and Exum Mountain Guides. And when he isn't working, he'll find him out enjoying the mountains with his wife, climbing, surfing, working on the house, sharpening snow saws for his company Primomo Snow and Avalanche, or attempting to cook Italian food as well as the rest of his family. We're really excited to have Matt tonight talking about decision-making in the face of deep persistent slabs in the Northwest. Deep persistent slabs are often a result of difficult to predict and highly destructive avalanches that occur with some regularity here in the Pacific Northwest. And tonight, Matt's going to take a look at some notable deep persistent slab cycles in the Cascades over the last 30 years, including the one that we experienced last year during the 2020-21 season. With all that in mind, he'll help us point towards where, when, and how we go about traveling safely in the mountains during these times of deep slab instabilities. Matt, thanks so much for joining us tonight. We really look forward to getting to hear from you.
Thanks a lot, Dallas. I appreciate it for the nice introduction. All right, you have me there?
I see your whole screen, Matt, not the, or your whole PowerPoint, not just the, yep, there we go.
Cool. All right, should be on now. So yeah, decision-making in the face of deep persistent slabs in the Pacific Northwest. First, I just wanted to acknowledge the Native peoples that were here before us on the land where we live and work. I just have a deep appreciation for them. So what is a deep persistent slab? A deep persistent slab is a deeply buried, persistent weak layer that gets buried over time by several storm layers. So this persistent weak layer can be any type of a combination of facets and crust, surface ore, or basal facets and depth ore. It can be very wide and very deep. Crowns are typically 3 feet deep or deeper and have been measured at 20 feet deep plus in the Cascades. So just a little video to get us going here. It's March 10th at Crystal Mountain, 2014. So they can do a lot of damage. What causes them? I ran into a really good PDF that I've added as a reference so you guys can check out. This decision-making in avalanche terrain by Pascal Hagley, Roger Atkins, and Carl Clausen. It has a lot of really good information on deep persistent slabs. It's like a number of pages. But a lot of this information came from them, and there has been a fair amount of research on what actually triggers deep persistent slabs as well. So basically any heavy accumulations of new or wind-driven snow, 1 to 2 inches per hour, sustained accumulations of 1/10 an inch an hour of water equivalent or more, any amount of rain, snow accumulations of 1 foot or 20 inches or more in 24 hours, strong solar radiation, especially after a time of cloudy weather, and air temperatures warming at a rate of 5.5 degrees Fahrenheit or more, especially if they rise above 32 degrees Fahrenheit as a result. And then one of the more important parts with this is any of these things happening in synchrony with each other increases the chances for them releasing. And the longer duration period that any of these happen, that also increases the chances. About the wrath of deep persistent slabs in the Cascades, we've got a long history of accidents that can be tied to likely happening as deep persistent slabs in the region, dating back to the Wellington accident of 1910, where 96 people were killed while waiting in a train because the train was blocked by an avalanche on the tracks. It was struck by another avalanche. John Andrews, the previous snow safety director of Stevens Pass, came out with a really good paper in 2004 about deep persistent slabs and his experience with them. And he was able to dig back and find that he thought the avalanche that happened at the Wellington disaster ran on some type of weak snow layer above a crust. Yodelin accident, 1971, in January, it destroyed 2 cabins and killed 4 people, including 2 adults and 2 children, and injured 8 more people. Then closer to present day, the Phantom slide path at Alpental. Luckily, nobody was around. Really, it was a lucky scenario, but it seemed to destroy about 23 acres of old growth forest and ran well into the parking lots for the ski area. So we've got a history with these things. The bottom line is that they've got potential to cause large scale fatal accidents and damages to infrastructure. So how often do substantial deep avalanche cycles occur in the Pacific Northwest? Roughly 1 in 3 years. That's what it seems to be. Since 1989, I found about 11 years with substantial deep persistent avalanche events or cycles. So we can look at this a little bit closer. I dug back into the old NWAC annual reports, accident reports, interviewed longtime professionals, and I didn't really use any hard and fast rule for listing these years. But generally, if there was a widespread activity in more than a few zones or a significant event within a single one zone, then I would list it. So the crown depths here are a range of what was observed or what was recorded, as is the D size that I wrote down. So as a review, or maybe new information for some folks, the D scale is the destructive force size scale that we use to measure avalanche potential. And so many of these events are happening in the D4 range. So what that means is they can destroy a railway car, large truck, several buildings, or a substantial amount of forest. And a few of the events noted some D5s, which are the largest avalanches known. So when we start to look at the pattern of deep persistent slab cycles, we have to first realize that they occur on a much lower frequency than many people recognize. So these widespread cycles that we're more familiar with, like storm slabs, wet, loose, dry avalanches, and wind slabs, we probably see, close tens to potentially hundreds of these happening in a season. Persistent slabs, just a random observation, no hard and fast data with it, but potentially 1 to 3 times a season here in the Northwest. And deep persistent slabs, through the work that I just starting to look at here, in the past 31 years, they seem to occur once in every 3 years. And to note with that, they can occur sporadically or they can occur in widespread cycles. And when they do happen, they run down into terrain where they don't very often. So the bottom line is we have really minimal experience with these events. So it's a difficult pattern to recognize, and therefore our decision-making due to it can be difficult. So what types of weak layers tend to create these events around here? Really interestingly enough, nearly all widespread cycles or substantial events were tied to facets and or surface core on a crust. or some combination of crust facet, crust sandwich, or like a trap crust where you've got facets underneath a breakable crust. So I thought that was pretty interesting to see. There were minimal events that did not appear to involve a crust, one being surface ore at Washington Pass in 2013-14. And there was a crust underneath the surface ore, but it's hard to say how much of a factor it really was. Basal facets and depth ore at Crystal Mountain in 1980, just from this old slide that I found. I don't have a whole lot of information about this, but this is the photo on the right here. March 1980. It looks like it was on some type of basal facets or depth ore. Some more text in there said warming. And then numerous events further east in the range, kind of the offshoot range of the eastern Wenatchee Mountains that appeared to happen on basal facets and depth ore. So I tried to break these up a little bit closer and see what types of weak structures are they happening on. Are they facets over a firm crust? Are they surface ore involved with the facets over a crust? Or is it some type of a crust facet crust sandwich? And so this is kind of what I came out with. Again, these are, you have to take these with a grain of salt, because as you go back in time, the information is harder to pinpoint down exactly what was happening. And then also throughout the region, in some areas you may have both or even all three of these happening in different areas for the same event. So we'll take a look into the January and February 2021 cycle that we had just last year. And it kind of fits the bill for a typical deep persistent slab event in the Northwest from what I have found. So the step number one is to create a crust and or crust through a high elevation rain event. Step number two is to have some faceting event or a long duration cold spell that can, you may get a little bit of snowfall with it, but eventually that snowfall that is above the crust or beneath the crust becomes very weak through a long duration cold spell. And then you need to build a slab. And you need not overload that persistent weak structure as well with a really big storm that gets warm and wet. So a long cool spell where you have a lot of snow, but no really strong warm-ups seems to be typical, and this is kind of what happened last year. So we'll dive into this a little bit deeper and just with some visuals around here. So it rains. The turkeys are walking around and they start post-holing in the wet trap crust. Followed by a cold, clear spell with minimal new snow for a period of up to many weeks. At this point in time, you can see slide for life conditions develop. You've got low avalanche danger. You can often travel anywhere in the mountains. You just have to be careful of really slick crusts. And so this is the pattern that's associated with the formation of weak faceted snow. And it can persist for a long time depending on what happens next. So here's a little video of January 22nd of last year up near Buck Mountain in the Chihuahua drainage. And there's little chunks of snow that are just sliding down. You can see there's some sparkling on the surface. It was really faceted, slippery snow. So this is what that may look like. Some clear translucent crust. You may have rain crusts, freezing rain crusts. And then enter your stormy pattern with cold temperatures and snowfall that occurs nearly on a regular basis. Frequently heard during this time in February was deep powder, blower pow, cold smoke, so deep. Also looking back into the previous events that I looked at, it was fairly common to see fatalities due to deep snow immersion prior to deep persistent slabs really coming to life. So people tend to soon forget about the facets and crusts that are at the bottom, which is the out of sight, out of mind mentality. But down near the crust, the storm zone may begin to harden and densify. So it's also pretty common to have persistent slabs develop before you have deep persistent slabs. This happens quite often. Wumping, cracking, remotely triggered slides. And after some time, these in-your-face signs of instability may begin to taper off. So by late January, we were seeing active deep persistent slabs in some part of the mountains. Most notably in the Mount Baker backcountry, they just got walloped by a series of storms, and I think they had 3 days of high avalanche danger in a row. And when the storms cleared, we saw deep crowns all over the place in that region. Elsewhere, it took more time. It took more snow to really make this weak layer come to life. The February 8th Knox Creek fatality was one of those that began to happen in the west side of the East Central Range zone. So it appeared that activity began to taper off after that, sometime in the middle of February, at least with deep persistent slabs. We had plenty of avalanche concerns. We had multiple layers of potentially persistent slabs, and we just weren't seeing a whole lot of deep persistent activity that occurred on this deeper mid-January crust. Even with snowfall rates of up to 4 inches an hour in some areas. But we did have 1 or 2 here and there. Then on February 20th, we had 2 human-triggered avalanches, deep slab avalanches on the same day in different zones and with minimal change in weather. This is a mostly sunny day. The thing is that the temperatures have been slowly warming. In one case, multiple old growth trees were broken. And in the other case, it was just a close call with some snowmobilers. So on the February 21st through 23rd, we had an atmospheric river come in, made landfall, and the forecast was for 3.5 inches of water in 24 hours. Very strong winds and rising temperatures. So we had a number of these things happening in synchrony. And we had a widespread deep persistent slab cycle in the Cascades. The roads were closed for a day or two. Some very large avalanches happened that from paths above the highways that don't happen on a very frequent return interval. So after that, deep persistent slabs continued, but they began to become less frequent. This is a photo of the West Camp path above Highway 2. And you can see some forest down here on the shoulder got ripped out, a very large air blast. And this is after the temperatures began to cool down again. And really notably with this event was the air blast was very impressive, and it dusted Highway 2 with a bunch of vegetation. And then by early March, we enter a period with high uncertainty. I thought Andy Harrington said it pretty well with one of his forecasts for March 2nd. We have had several rounds of deep slab avalanches over the past few weeks, and many have been erratic and hard to predict. We could go several days without seeing another deep release, or we could see multiple happen tomorrow. So the photo here shows an avalanche from Union Creek in the west-south zone, and just a little question mark if it was triggered by solar input or if that had something to do with it. So Conlon and Jameson have some good research on that and some of the resources that I added. So with decision making, we've got difficult and complex situations regarding repeat offenders. Sometimes the slope may reload and it can run again and again. Here's a photo of Chair Peak on February 24th on the left. And if you look closely, you can see some debris from avalanches that were probably in the size D2.5 to 3 range that happened from the atmospheric river on the 22nd, more or less. And then on March 1st, this thing ripped out in the middle of the night as a D4 with a very deep crown. So it appeared to have run more than once. And the second time in early March, it ran much deeper. Here's another example, Henry Creek and Stevens Pass. We had a close call on February 7th where a party of 2 were involved. The avalanche released on the second lap while skinning. And after the atmospheric river, it appeared that the path had run again, but much larger, and it broke many trees, filled in the path quite a bit. It ripped some tree, it basically created or cleaned out some new terrain. So some more factors that influence uncertainty are slow or slight changes in weather that can be seemingly insignificant, such as moderate snowfall, direct sun, and warming that can activate deeper layers, especially on a longer duration, like warming over a number of days. We can see multiple active periods between dormant periods. So this pattern is difficult to recognize, especially when we only have these things happening once every 3 years. The surface condition doesn't really indicate much because the weak layer can be buried so deeply. Sporadic avalanches can go unviewed due to no one around to see it, or a combination of that and lengthy periods of time with minimal visibility. A lack of typical signs of instability, such as cracking and woofing, doesn't necessarily indicate stable slopes. Again, these weak layers have become buried so deeply that we may not affect them until perhaps we do. So once again, difficult and complex situations regarding repeat offenders. And then with terrain choices, it can be very difficult to correctly gauge how far a deep slab event could run. With snowpack tests, they become fewer and far between as the weak layer gets buried deeper and deeper. They become time-consuming, difficult to do correctly, and less conclusive. But we continue to look for signs that people can trigger deep, persistent slab avalanches, and we continue to dig. And we hope you do too. Compression tests, extended column tests, these are really only good down to about 100 centimeters. Deep tap tests, these are good. Sudden planar and sudden collapse results are what we're looking for here. And propagation saw tests, these can be time consuming. However, we still obtain meaningful results with them. The interesting thing with deep slabs is that results with the saw between 40 and 60% of the overall column length. If it propagates to the end, that can still indicate instability for deep slab releases. So one more graph here, a floating bar graph of how persistent can these things be. So we're looking at is the years that I analyzed a little bit closer, and the days from November 1st throughout the season. So for example, day 30 is December 1st, more or less. Day 60 is January 1st, more or less. And on the left side of each bar is the date of the formation of the crust. And the right side of each bar is the last avalanche that was recorded or that I observed happening. So many of these events can span multiple months, and some even more than that. All right, so a few more decision-making strategies here. I had to reference the pop culture show Ted Lasso as well, after I saw Rob do it the other day, because I thought it was a pretty good idea. So Roy Kent here, he's one of the characters in the show, and he doesn't say a whole lot, but what he does says means a lot. And so I kind of thought it would be fun to use him. So, the first thing is to recognize that you're dealing with DPS. Discuss it within your team. One recent occurrence in any zone nearby should take precedent. It's kind of like that canary in the coal mine that Sarah Carpenter was speaking about. Was it a surprise? Is it going to lead to more? Could the area that we go have similar problems? So begin by planning with a more conservative approach to terrain choices. Also, don't underestimate the full potential of a deep slab avalanche. They can run through and break trees and propagate across multiple features. And also the air blast can be really impressive with them. So seek out smaller pieces of terrain. Avoid larger pieces of terrain and those with multiple overlapping zones. Stay off of and out from underneath slopes steeper than 30 degrees. A little bit more with the decision-making strategies, timing. avoid exposure altogether during and after periods of time with heavy snowfall, rain, wind loading, warming temperatures, and strong sun. So those are the key factors that can help trigger these things. If you're going to expose yourself, keep it to a minimum and avoid potential runout zones on the way up as well as on the way down. Exercise self-constraint gives the slopes several days to adjust to changes in weather before you begin to gain in confidence with deep slabs. And stack the odds in your favor. You are likely to see other people traveling in terrain they have decided to avoid as a team. And just because they don't trigger an avalanche does not mean that you made a bad call. Well, that's all I've got. Hopefully I have time for a few questions, but thanks a lot for all the great observations that have led us to make this presentation and all the photos. Appreciate it.
Great, thanks, Matt. We have just a few minutes for a couple questions, and I'll kick it off while maybe some folks are typing a few in here. But Matt, you were mentioning that these things are, they're not as frequent as we see with, say, storm slabs, wind slabs, loose style avalanches, where we may only see these once and every 3 years, or maybe even some cycles, the bigger, more widespread ones, maybe once in a decade or once in 20 years. For you as a forecaster, how do you set yourself up to anticipate these cycles or not get caught off guard by them when they do occur?
Yeah, that's a good question. Well, we're always tracking the snowpack. We're always digging. I keep track of all the different layers that form throughout the season. As we go through the season, and some layers tend to stick out as persistent layers. Those are the ones that I really make a note of and begin to follow and track throughout the season. So that's one of the big things, just tracking layers, making sure we know what's going on with those potential layers and the distribution of them.
And then I think Doug asked a pretty good question that kind of dovetails in with that. We have persistent slab cycles here, not infrequently. I think you mentioned like maybe 1 to 3 a year. And I definitely think, we see them probably more often than sometimes we even recognize. When do these things transition really from being a persistent slab into a deep persistent slab? Or what are some things maybe as a forecast center we're using to make that distinction in our evening forecast?
Yeah, it's certainly not a hard and fast rule, and it's something that we have a discussion about all the time. But some of the things that we're looking for are 3 feet deeper, but then also the character of how the instability tends to react. Like, are we getting in your face feedback all the time when we're out there? If so, then it's probably, we're going to tend to call it a persistent slab. And not necessarily all the time, but if you walk on a slope and maybe like 30 times out of 100, you get some feedback, we're probably going to call it a persistent slab. Once that begins to taper off over time, but we still get isolated releases, then that's when we might start to call it a deeper slab. And then just the depth to it. So
yeah, so it's kind of the general depth, and that general depth has something to do with how responsive this thing is and how much information, or at least obvious signs of instability, it may give us. And then Colin asks, he says, great presentation. He says, could you go back and maybe discuss if any stability tests, like we're mentioning, we're not getting that direct feedback from the snow as maybe we're walking around, and we obviously were digging a lot. Some of these holes were 10, 12 plus feet deep last year. What are some of those tests that we are relying on, and maybe even emphasize a little bit about what you're actually looking for out of those tests?
Yeah, totally. Well, yeah, once the weak layer gets buried, deeper than 3 feet, then we really just start to do deep tap tests and propagation saw tests. So deep tap test is when we're digging down and we're essentially doing a compression test. So we've got a 30 centimeter by 30 centimeter column. However, we take off the overburden and we place the shovel just about 20 centimeters above the weak layer. So that way you can really see what is going to happen if you somehow affect the weak layer. And we're looking for clean, fast planar shears. So sudden planar or sudden collapse, if the column actually drops a noticeable amount, that is called a sudden collapse. If it pops off really quickly and clean and planar, we might call that a sudden planar release. So those tend to indicate the potential that we could propagate an avalanche on that layer.
Yeah, so kind of back to that, it's the quality more than it is actually the number. That's great, Matt. You've generated a lot of really good questions, and honestly, Matt, I wish we had more time to keep discussing it, because I know for us, these are oftentimes long discussions in forecasting meetings. So if you have a moment, maybe after you jump off, if you can go in the Q&A and answer some of these, that'd be great. But I want to end with one last one. Dan Bienheisen from the Stevens Pass Avalanche forecaster for the ski area there. He said, a great presentation, Matt. He just asked, do we see these deep persistent slab problems exist in most or in all zones during those 11 seasons that you pulled out? Was it kind of more widespread, or did you see them oftentimes more localized?
Yeah, that's a great question. Most of the time we were seeing them in many of the zones, not necessarily all of them. Like Mount Hood, for example, kind of stands out as an outlier in the range. The Olympics tend to stand out as an outlier. The east-north zone, a little bit colder up there, generally have less crust that form because of that. But by and large, the central Cascades, from the northern Cascades down through like the southern Cascades in Washington State, we're seeing a lot of these standout events all kind of happen in a widespread fashion at some point or another. At least they were mentioned more often than not in those events that I listed.
And I think that's why one of your points really struck me was that an avalanche in any of these areas, because the conditions are so widespread, an avalanche at Stevens Pass is really relevant for me today, even if I'm traveling down at Crystal or Snoqualmie Pass. And so with these bigger events that are really widespread like this, sometimes maybe taking a broader view. And we try to do that in our forecast, obviously, but that's something that you said tonight that really stuck with me. So. Matt, again, you've got a lot of good questions over there on the side and generated a lot of good questions for us. And I'm sure we're going to be revisiting this as a staff again this year as well. Thanks so much for taking the time to speak with us tonight and for all your work on that research this summer. It's really exciting to see.
Awesome. Thanks a lot.